As we all know, IoT devices are not always connected, whether because connectivity is not great, or because the device is roaming, or because you don't want your device to be connected directly to the internet. But at the same time, you need to update your devices, right? That's what you're told. Andy is joining me on the IoT show today to do an update on a Raspberry Pi that is not connected to the internet. That's today on the IoT show. Don't miss that one. Hi, everyone. Thanks and welcome to the IoT show. I am Olivier and I'm really pleased to have you. Today, we will talk about updating devices that are offline or disconnected. Pretty weird topic, but super interesting. And for that, we have Andy with us. Andy, hey, how are you?
I'm good. Thanks for having me.
So, Andy, before we jump into that topic and you tell us the story of the why and how, tell us a bit about yourself. Who are you? What team are you working for at Microsoft? And what is it that you're doing?
So, I'm a program manager, and I work on a team that owns a product called Delivery Optimization. And I'm specifically working on Microsoft Connected Cache, which is an edge cache for downloading content, which is downloaded by Delivery Optimization.
Okay, so we're just after the Microsoft Ignite event, during which we announced a new feature called the Device Update for IoT Hub that allows managing your updates for IoT devices, pushing binaries like firmwares onto devices, all of that managed by IoT Hub. What you came here to talk to us about is how you can implement that on disconnected devices. So very intriguing, but let's discuss the scenarios. When is it that IoT devices are disconnected? Because in IoT, there's something called like internet. So you expect devices to be connected, but in reality, they might not be. So what are the scenarios where we need to push updates onto devices that are not connected to the internet?
Well, this is actually a super common scenario, and there could be a variety of reasons, mostly related to security, in cases where you have where you have automated factories, you have advanced robotics, and potentially in the future, even and now, smarter homes where you have devices that you don't want to talk directly to the internet, even though they could. Um, and also, you may have scenarios where you have devices that are potentially intermittently connected. So, for example, that ship that is going from port to port, and then when it comes into port, it has great internet connectivity, but when it's out at sea, maybe it's got a very expensive or very slow bandwidth. And so you actually don't want devices talking to the internet then. I even talked to one particular customer who had a remote manufacturing site that only periodically had internet connectivity that was brought to it. So it's basically any scenario where we have an IoT device that is isolated from the network for reasons of your choosing.
And I'm sure our audience understands that really well, because for all of you that were watching now and are doing IoT developments, you are, one of the questions I get the most often is, where do I get the information whether or not the device is connected? Because actually very often it is not, and you might not know it is not. So usually a device update is about having the device pull from some location, usually the cloud, a firmware, an image, right? And bring it down. And we won't talk about the implementation details for the device update feature itself, but tell me a bit how we can achieve that update when devices are not connected. What is it that your team has been developing with the Azure IoT group that will enable that?
Sure. So, as I said, I work on a team called Delivery Optimization, and Microsoft is providing this IoT Edge module called Microsoft Connected Cache, which is in preview and that works out of the box with Azure Device Update. And so basically, we've taken that same downloading client that is on all of the hundreds of millions of Windows devices out there in the world, and we have built a light client version that runs on IoT devices. And so with that client, it then knows to pull content from the cache rather than pull content from the CDN. I'm going to show a diagram here from our documents, and that'll kind of help to explain things a little bit here. So I'm actually going to start from the bottom, and so this would be your typical IoT, device. And here we have a device update for IoT client that is running on that. And then here at the bottom here, acting as the downloader, we have our delivery optimization SDK and simple downloader. And so basically that simple downloader, when it receives a request to download content, it is going to, instead of downloading content from the CDN, which we see out here in the cloud, it is going to take the IoT Hub connection string, which sets that gateway host name to its IoT Edge gateway, and it's going to say, you know what, I'm going to pull this content rather from the CDN, I'm going to pull it from this IoT Edge gateway. And so it's a specifically formed request, which then goes to this Microsoft Connected Cache IoT module that's running on the edge. And that IoT Edge module goes out to the CDN and pulls that content back, and then sends it back to that client that made that request.
Nice.
And
Basically,
as far as the IoT client is concerned, it doesn't know the difference. It thinks it's downloading from CDN. It's just another source.
Super clear. So the IoT Edge device now is acting as a proxy, right? It's able to gather the various updates for the various leaf devices, because here we are showing a diagram with only one device, but I guess it would work with different types of devices as well, where you actually have different images ready that have been downloaded from that CDN on that edge device in that local storage for these various devices to be able to get that updates as they're not directly connected. Love that. Pretty straightforward. Before you show us how that works, can you tell us about your setup? What do you have on your desk, and what is it that you're going to run all of that on?
Yeah, so I'm at home, and in my home, I have a trusty old IBM X1 Carbon ThinkPad that's acting as my IoT Edge gateway. It's hardware. It's sitting right here. And then right next to it here, I'm going to move it just a little bit so you can see it. I have a Raspberry Pi 3 that's acting as my leaf, my leaf device. And just to show you here, I'm going to go to my screen here. I'm going to show you. So this is my Raspberry Pi leaf device window right here, and I am SSH'd into that, and I'm going to ping Microsoft just to show you that this leaf device is internet isolated, and it is. Okay. And now here's my Edge gateway device, and I'm going to ping Microsoft.com here.
And this one connected. Okay.
It is connected. And then what I'll also show you here, I'll go back to my browser. And in my browser here, I'm going to show you my twin settings here. So this is my device twin for my Raspberry Pi Leaf, and then and so you can see here that I actually have a special tag here that is grouping it for this Azure device update. And then we can also see here that this is my IoT Edge gateway, and this is the module setup for the Microsoft Connected Cache module. And I'm only going to highlight a couple of the key settings here. One is the storage size, And so you will be able to customize how much space you would want to allocate to the cache on your disk that is running this Microsoft Connected Cache module. And then also, if you wish, you will also be able to then have a custom location of which disk you would like to have the cache stored in. So in this case, it's on disk. It's called Microsoft Connected Cache 1, which maps to the folder within the running module, Edge module. And so that's pretty much it. And then beyond that, I have all of my configuration for updates and groups that I can show you for this particular update that I'm going to deploy. So if you'd like to see that, I can show you that.
We can definitely look at that real quick. Before you jump into that, I have a question. You were talking about the size of the storage here. I mentioned the fact that eventually you have several devices. Are there limits, or is it something that really depends only on the hardware you have?
Yes, correct. It is only limited by the hardware that you're running. And so currently today, with the Azure Device Update public preview, our IoT Edge module is supported on x64. And so if you're running this on server hardware or even PC class hardware, if you wanted to, for example, it's only going to be limited by the storage that you have on that machine.
Okay, so let's look at this deployment in the device update. It's the usual, deployment, right? There's nothing really different from the Azure device update for IoT Hub configuration perspective, right?
Correct. Absolutely no difference. And in fact, if we look here, I actually have two updates that are deployed. I'm going to go ahead and maximize the screen just to make it easier to show. But I actually have two updates. And so I have a previous update that I had deployed on Friday, and I'm actually going to go ahead and create I'm going to create a new deployment. And so I'm just going to go here and create new deployment, and I'm going to select my device group. And so I'm going to select this group right here. And this group is a group that I had already created that has this Raspberry Pi as the one member of that group. And I'm going to select a start date in the past for this update, for this update deployment, because I want this deployment to start immediately.
Yeah, so that's the trick for the demo here of device update. Put a date in the past. Like
exactly. And so then I'm going to go ahead and go create deployment. And I'm going to show my Raspberry Pi here, and I'm going to be running journal control. And actually, we can already see that this device, it's already started to download the file. So we see here, downloading file, right? Okay. And also, if we look at this path here, I'm going to try and zoom in a little bit so you can see. Maybe that's not quite going to work, but you can see that this is an HTTP path here. And this is actually the client, the ADU client thinks it's downloading it from the cloud. But in actuality, what's happening in the background is that the DO client says, oh, you know what? I know that I should be downloading content from this cache server, and so I'm going to make that request to this cache server for content. And so that's happening in the background, and that's just going to take a moment here. But then one thing I can show you here also is that in my device twin, if I refresh this now, we can see that there is a new update manifest for a desired state that has come down. And this includes all of the necessary details for this client to begin the download of this update here. And so we'll just wait a little while here for this content to come down.
Okay. Can I ask a question while he's doing that?
Sure.
So at what moment, in what did you have to do, if anything, did the update actually get to the IoT Edge box? What needed to happen for that cache to be having that firmware update?
Yes. So the moment that the client makes the request for content, and when the DU client forwards that request to download to the DO client, at that point it seeds the cache. But you could see that if there were, say, multiple of these IoT, of these Raspberry Pi devices that were downloading the same content, once that first request is made for that content, it seeds that cache. And once that cache is seeded, then it's all good to go.
Nice, nice. So like the first time there's a request, the right update is pushed down to that gateway, to that IoT Edge gateway, and it stays there, for as long as it's needed. And the other question I had for you is, from the security perspective, what's happening both in terms of encryption at rest for that binary, for that firmware that is actually on that IoT Edge device, and what's happening as well in terms of guaranteeing the integrity? Is there I know device update actually uses hashes in the manifest for the device to be sure that the binary is legit, right? Is that something that is still part of that story?
Yeah. So MCC is forwarding those proxy requests. This is actually a really great question here. And so it's important to understand that there is no altering of any of the security process for device update, which has already been documented. And in fact, you can see that update manifest signature. This is essentially just a local CDN, and that manifest hash is signed, and the client is still performing all the same validation that it would perform as if it were coming from the cloud.
Nice. Yeah. So the goodness is that from the device developer perspective, whether you go through that MMC module or you go directly, there's no change of code on your device side of things, right? It's exactly the same scenario.
Exactly.
I like that.
Exactly. Yeah.
Okay, let's check out this Raspberry Pi to see where it's standing.
Okay, so download of the file has, hopefully it's progressed here, and we're just waiting for a download complete message.
And all this time that it takes to download the files and so on is really dependent on the size of the files, on the network quality, and the type of device you're using. So yeah.
Exactly. And actually we see here that the download has completed. See, we see a message, download succeeded. And now I'm actually going to do a little magic here because I want to take a look at these logs. And I have a couple of delivery optimization logs that I'm going to look at here. And I'm going to look at one of these logs, which shows the download, and this is going to be the key here. So this is really what we were looking for. See this path right here? This is actually the path to the Microsoft Connected Cache module, or I should say the machine that's hosting that Microsoft Connected Cache module. That's its IP. So in the background, just like I said, that client, DO client, has taken that requested URL and said, but you're actually, you should be requesting from your edge cache. So I'm actually going to make this request. And so this is actually the origin that file came from. And actually we can see here that it has gone through the process of downloading the update. It has validated the hash, and it has gone ahead and rebooted, and it's going to reboot into that new image. And so we have our machine, and it has closed the connection, and it is rebooted. And now I'm going to go back to my deployment here, and I can see that I have 2 deployments. And this is the deployment that I just sent here. Actually, I'm going to go here in this view. This is the deployment that I just sent, and we can see that it has succeeded. And
Nice.
I'm going to show you the twin output here. And as I had showed you before, here is the desired state update manifest that was sent down. And if we scroll down here, we can see that there was an installed update. And so if we see here, there was an installed update, and we can see here that that this is that version that I just installed. So just in quick summary, right? We had that Raspberry Pi that was parented up to an IoT Edge gateway. We had DU send down an update. It took that update, it downloaded that content from the Microsoft Connected Cache instance that was running on that IoT Edge gateway.
Brilliant. Brilliant. Super clear. Nice demo. We saw all the steps you just described. Well, thanks, Andy. I think we're going to see you again soon on the IoT show for a bit more complex scenario of device update in the context of an industrial manufacturing scenario. I think something like that, right? It's just a little teaser.
Correct. Absolutely correct. Yeah.
In the meantime, but people want to learn more about device update for disconnected device, there is that link, which is aka.ms/IoT show/update disconnected devices. Andy, thanks again for your time, for a great demo. Everyone, thanks for watching the IoT show, and see you soon. Bye.